Welcome to the Gridwise Architecture Council's video library. This is a library of presentations given to the council members and invited guests during our monthly meetings. The following presentation, presented by James Mader of Quality Logic, was given to the council on August 16, 2023. The title of his presentation is V2G is Real and Complicated: V2G Critical Success Factors and Harmonizing Standards. Please welcome James Mader.
Okay, so this presentation I've been doing. We've done our own webinars, plus I did this at there's a conference called EVS, and this one was 36 in Sacramento in May, and it's kind of the longest running EV focused conference. And this paper was essentially accepted as part of that conference. It was actually written up and included in the proceedings from that conference. So it's basically we've been focused on the standardization issue around V2G. I'm not going to spend too much time on standardization itself, because from a GWAC standpoint, the question is, what is relevant to GWAC, and is there a role for GWAC to take in dealing with this whole vehicle-to-grid issue? So what I'll do is focus on some of the nuances that I'm not sure everyone here is aware of, and then we can dialogue after that if you want. So first of all, you've already had an introduction to me. I've actually got another picture here I haven't taken out yet. That's my general manager for the Smart Grid Group. But I've been working with standards, and I've spent the last over 2 years now focused specifically in the EV world, with a question both from a personal and a business standpoint of what's going on there, how's it evolving, and is there a real opportunity for this V2G stuff that we're talking about? So let's talk about what is V2G and why does it matter, because I think that's what's really important here. So we think of vehicle-to-grid integration. I mean, there are a number of terms that float around. California used VGI. There's a trade alliance called VGIC, which is Vehicle Grid Integration Group, which is mostly or council, which is mostly the automakers, and it's run by Stratagem. And it looks out for the interests of the automakers relative to EV infrastructure and policies related to that. So vehicle grid integration sort of covers the whole question of how do you integrate electric vehicles and buses and trucks and everything else into grid operations. And one of the focuses is simply on the demand management, the charging demand. A lot of people call it managed charging. But the second part is, how do you take advantage of those EV batteries for grid support and start treating them as distributed energy resources the same way you would a battery storage system or solar system. And so how do you do that given where we're at in the industry, and how do you plan for it? So VGI kind of covers all of that. V1G is typically referred to as one-way power flow with communication, and that's really to influence the charging schedules. Again, a lot of people talk about that as managed charging, to just ensure that you don't have everybody or fleets plugging in at 5 o'clock and putting a whole spike in the load on the grid when it's not necessary. V2X is sort of a generic term people have adopted for vehicle to anything. So you can think of a vehicle as a battery backup power, like the Ford F-150 is to a home or a building. It could support another vehicle. And there are other applications. Rivian is kind of pioneering the whole idea of backcountry. You've got your hunting camp or whatever it is, and you want to provide power from your vehicle to that hunting camp. So, or just a recreational camp. V2G is where you've got bidirectional power flows and the communications to manage those. So when you get to V to G, and a lot of people have trouble with this, when you get to V to G, it is very different from managed charging. Because first of all, you've got to have an interconnection agreement with the utility and you're exporting power to the utility. There's a whole different set of requirements, regulations, parts of utilities that deal with that versus the charging side itself. And you need to have all the grid support functions to meet the requirements for interconnected resources. And these are very specific functions defined primarily by EEE 1547. And the functions are really aimed at stabilizing the electrical grid at the local level or at the macro level if needed. So that's V to G. Now, how do we go on to the next one here? There we go. So EPRI did a study back in 2019, or they published it in 2019. They looked at California very specifically to try to answer the question of what would be the value of V to G if we implemented it correctly. And so they looked at, let's see, let me get some notes up here. They looked at unmanaged charging, right? And what they saw is that there's basically a net cost because utilities have to put in more infrastructure to support the charging if it's not managed. If you manage when the charging happens, you reduce that incremental cost to the ratepayers of supporting it because you can now, determine when that demand is going to happen. But when you start looking at using the batteries in the vehicles for grid support, boy, the game changes. It costs more, but the benefits are significant. So this is, the cost to benefits of doing managed charging. And the bottom line from that study was for California alone, they computed upwards of $1 billion a year in ratepayer savings for using and vehicle owner benefits for doing V to G. So that makes it a really compelling, really compelling topic. So there's just some notes here about level 1 charging. If it's standard 120 volt connection, the rate of charge is comparable to running a dishwasher or microwave. Level 2 charging is like a 220 volt, and that can create a load of 2 to 5 times greater than a typical household. So this is where managed charging gets really interesting and important, because if you've got a neighborhood with a lot of EVs, now you're stressing the grid infrastructure that was put in place to support those houses. So there's also issues with when are EV owners charging, and at least 20% of them charge at peak hours. This was part of the study. So, that becomes useful. If you can just manage some of that, you help the grid significantly. So again, we only looked at, I wasn't part of this study, but EPRI only looked at California, and with an estimate of 3.3 to 5 million EVs by 2030. So again, I mentioned these conclusions, and I think this is important for the council to know if you want to get deeper into this subject, it's a worthwhile topic to look at or study to look at. So there's another interesting back of the envelope calculation. EPRI never does anything back of the envelope, but in reality, by the time you look underneath the hood, you say, yeah, they're really making a bunch of assumptions. And by back of the envelope kind of calculation, they estimate that the total EV battery capacity will exceed the total U.S. peak electricity demand in 2030.5. Okay, so think about that for a little bit. So this is a curve of the total battery capacity that is connected to the grid for charging purposes. But that's enough, if you could flip a switch and use that and reverse all that power flow, you could operate the whole grid for, I don't know whether it's minutes or an hour or two, but you've got a tremendous amount of capacity there. they tried to model out, if you've got, less percent, and this has it in here, you just get some percentage of that battery capacity to use for vehicle to grid, what happens. But however you look at it, there's a huge opportunity here. And I was thinking about it this morning, and from a council standpoint, this is important. I think this is a game changer for the industry, and it's important enough that the council at least ought to be asking the question, is there some contribution the council could make? And I don't know offhand what that would be, and it may take some time to answer that, but that would be my bottom line message from this discussion. So the other thing about EVs, once you start treating them as distributed energy resources, we already have in place a way to do that. We have in California, it's Rule 21. We've got IEEE 1547 that defines what's required to be an exporting distributed resource. In California today, you could do bidirectional power flows if you've got a certified, it's a UL 1741 SB certified charging station that is DC and has bidirectional power flows. It could already be a resource today, and in fact, some of the vendors are already doing that. But of course, when you start using EVs, I think it's probably one of the most complex potential resources that grid operators can use. And primarily because it is, really purchased by the homeowners for their own use as transportation. So you got scheduling issues, you got charging issues. For a long time, the automakers were saying, well, you want to do bidirectional stuff, you're going to void the warranty on the battery. Now that's changed. But there's a lot of complexity when you start adding EVs as resources. Now, but in order to do that, again, it seems to be a compelling enough opportunity that we're looking at it really, really hard. So in the IEEE 1547 group, we've got a task group looking specifically at how to make 1547 more friendly for V2G in the next update. So, and just as a note, so these are all the, this was a few months ago, but these were all the automakers that had announced bidirectional charging support in one form or another, whether it's, just their onboard battery system, whether it's putting an onboard inverter itself there, or working with a charging station that supports this. But all of these vendors have announced support for it and are working on it. And then the other factor is the batteries are getting bigger and bigger, right? And so you've got more capacity sitting there. And you think about a passenger car, take a Lucid, which can get 500 or 600 miles on a charge. And for the most part, that thing's going to be sitting in some expensive garage someplace, hooked up to a charging station, probably level 2, and not doing anything, right? Or maybe taken out to go get groceries. You're going to barely touch the charge on that thing. So it could be a very effective, V2G tool. So, these are a couple of really interesting trends in the industry that are bringing this to a reality. So I'll mention just briefly the interconnection side, and there are two primary use cases for V2G. One is what we call V2G DC, where you've got the inverter, and this is now has to be a UL certified inverter on the charging station itself, okay? So, and then you use DC current between the charging station and the battery itself. So from a grid standpoint, this looks like a DER. And, from a, as long as a charging station can do all the things required of a utility to be an interconnected DER, it doesn't really care what's behind it in terms of how it's managing the battery and how it's communicating and everything. Because the only thing it's really doing is just reversing the power flow. and the cars have to have that capability. But other than that, this is a DER. The other case, which gets more intriguing and more complex technically, is what we call V2G AC. There is this is an SAE, Society of Automotive Engineers standard called J3072, which basically leveraged the IEEE 1547 interconnection standard and say, okay, let's put a smart inverter on the vehicle itself, and let's have the charging station just pass through AC current. And so now that inverter on the vehicle becomes a DER, and also then has to meet all the requirements of a utility from a DER standpoint. So the reason, why would you do this? Well, there are two reasons, two main reasons to do it. One, these charging stations that just pass the current through are a lot cheaper than having a full inverter from AC to DC on that charging station. The second reason is this vehicle becomes more valuable as a V2X kind of vehicle. So again, you look at the Ford F-150 Lightning, and it is so popular they can't make them fast enough because people want to have their vehicle as their residential battery backup during power outages. And you can't, you can do that when you put a smart inverter on the vehicle. And so that's the second reason for doing this. And I know seriously, many are actually investing in doing this. So I just want to mention this from just to get these two use cases in everybody's mind. And let's see, what do I want to do next? We don't need to talk about Europe. We had a conference in the spring, actually in the winter, at the end of February at Southern California Edison, hosted it at their training facility in Irwindale. And we call it the V2G Forum. It was the first of its kind. And Jamie was there, and I don't know if anyone else on this call was there. I think there were a couple of people that may have been. But it was a very successful conference. We had about 100 people, and I sort of expected that, but most of the people that came there were kind of blown away by the number of people working on V2G. And they didn't realize, comments were, hey, we didn't realize there was so much interest in this area. And so one of the things we did at the conference was to break everybody up into groups and say, okay, what are the challenges we need to solve to get V2G to go to scale? And so here's kind of a summary of what came out of that. The first challenge was end-to-end standards and certifications and interoperability. That's a huge issue right now. And that was what generated the V2G forum in the first place. And a corollary to that is harmonizing the standards, which is a big barrier because we've got the Europeans doing a set of standards that are being adopted in this country for charging, but are not adequate standards for supporting V2G. So how do we do V2G on an infrastructure that doesn't support it? Then, there's also a big financial issue. Nobody really knows how to quantify V2G to make it a viable business. There's a lot of pilots that have been done and experiments with incentives and pricing and stuff, but they're all one-offs. And we don't have really any good models yet for how to make V2G a viable business proposition for all the players involved. There are people working on it. California's got some really interesting ideas, and others are working on it. But so that's a big barrier. Also, the distribution utilities are woefully unprepared for dealing with this. Their idea of dealing with electric vehicles at this point is how do we get the power to the fleets that want, all of a sudden they want 5 megawatts, and we were supplying them with 1, and if they can wait 2 years to electrify their fleet, we're fine. But if they want to do it in 6 months, we're out of luck. So that's where, utilities are pretty much focused on how do you get the charging infrastructure and the power to all these charging stations throughout the country, let alone thinking about, well, what if we're going to do bidirectional power flows? How do we integrate and manage that? And, chicken and the egg, right? I had one big auto manufacturer corral me at this EVS conference with the question of how do I justify in $1 billion program to put inverters on vehicles? How do I justify making them grid support inverters, making them go all the way in that? And part of the answer is, until utilities have programs that make it worthwhile to do that, we got a problem. It's hard to justify. And so it's sort of chicken and egg right now. Then there's some real regulatory issues. Doing an interconnection of a DER is a big headache and is really designed around solar inverter systems or storage systems. But, someone goes out and buys an EV from a vendor and they plug it all in. It's like if you want to do V2G, that's a whole different ball game. Then, of course, there's the customer experience. How do we do vehicle to grid in such a way customers understand it and support it and benefit by it? Then there's issues of battery technology and workforce development to do all this. So some real interesting challenges. Again, thinking about where GWAC could, make a contribution. I'm not sure. It might be in the area of utility preparedness. It could be in the area of standards. Could be in the area of value quantification. I'm not sure. So I'm going to spend just a minute or two on the standardization side, and then I think we'll just bring it to a close. So, all right, so since it's an architecture council, I tried to sort out this V2G stuff in an architectural layer. And it's really interesting exercise to think about it. So if you look at the communication and the power flow for V2G, you've got a utility, some sort of DER management system. Somehow utility needs to be aware of and want to change the behavior of the vehicles as grid support vehicles. Then you've got an intermediary, which is probably a charge network operator, but it could be an aggregator. There could be 2 or 3 intermediaries between the utility and the actual charging station. Then you have the charging station itself, which manages the flow of power to the vehicle. And when you start doing V2G, you have the reverse of that. So you've got a whole bunch of functional layer, like the charging station can charge and also can act as the gateway to the utility for V2G. Then you have a physical and network layer. Normally, I wouldn't think too much about this, but for those familiar with the charging infrastructure itself, it took me a while to understand what a nightmare it is. It's basically all around a cable. And the way the communications has grown up has been through something called a pilot wire on the cable, on the cable itself, using a standard for communications, which is pretty low level, and there's not a certification for it. So this is a very it's an unshielded cable in terms of communications. You can plug into a bank of 4 or 5 charging stations. Your vehicle will not know which one it's talking to because there's so much noise, right? So all the charging stations will respond. And so there's a whole thing called Slack, which is a way of going through and actually verifying, okay, are you the charging station I'm actually talking to? And so once that's confirmed, then you can go ahead and say, okay, now you can charge, send power through that cable. So, and then there's the whole question of the actual plugs. And I'll talk in a minute about what Tesla is doing to that discussion. So there's a European standard for plugs and there's a US standard for plugs. The European standard incorporates the US standard. The US standard does not incorporate the European standard. So you do have a physical layer, and then you've got the network layer, as I mentioned. Then you've got, on top of that, for V2G, you got to deal with the messaging side. All right, how are you going to send information back and forth to the vehicle or the charging station or both of them to enable a V2G activity? And so I've got some of the protocols listed here, and you have this mishmash of protocols that can do the DER management that come out of our IEEE 1547 world, and the protocols that do charging management that come out of the ISO and European standards for managing charging that are being adopted in this country. So, so we get all this very, very messy. We published a white paper said, "Are you confused about V2G? You're not alone." And and it's a fairly long one that goes through all of this and tries to sort through what the standards are, what they do, and what they don't do. So so that's from an architecture standpoint. I talked about and then we've got the other factor here, which is V1G has been, or managed charging has been dealt with sort of irrespective of the potential for V2G. So you've had a whole ecosystem grow up around using, if they're going to use a standard, it's OpenADR to communicate from the utility to manage the charging side. But if you do that, you cannot really use OpenADR very, very effectively to manage V2G. So I mentioned V1G because that's the direction that the industry's been going, is to do a very simplistic way of demand response, essentially using the vehicles. So then I've mentioned the V2G DC, and I'm not going to go through the details of the standards here, unless there's some questions about them, and the AC. We also have an interesting situation where some of the Europeans are saying, we have different grid codes in Europe. We don't need to do all the crap you're doing in the US. So we've got a clever idea. We could actually do a bunch of the requirements for V2G AC on a smart charging station and manage the onboard inverter that way. Well, there's no standards for doing it yet, but it's an interesting notion that a number of very smart people have been pushing on. So I'll mention about harmonizing US and EU standards, and I want to show you why that's an issue. So basically, the infrastructure in Europe is ISO 15118. That governs the interconnection, all the communications between the charging station and the vehicle. And there's something called OCPP, which is Open Charge Point Protocol. And that governs the management of the charging stations from a network operator. In this country, we started down the road of adopting these two standards. It's part of the NEVI process for the Infrastructure Act. California was mandating requirements to support these. But on the V2G side, let's see, I think the next slide. This sort of explains it. We got two major issues. First of all, the model for charging is that it's the vehicle that's in charge, okay? The vehicle pulls up to a charging station, you plug in the cable, and the vehicle says, "Hey, can I get a charge?" And and then it says, "Okay, I'm charged, now stop." And or change the rate of charge or do something, but it's the vehicle that's in charge. If you want to do V2G, the utilities want to be in control of that. They want to say when to discharge, right? And when to charge, for that matter. So you have this sort of, disconnect between the control model, between the emerging standards for charging and what you need to do for V2G. Now, the other factor in V2G is grid support functions, right? So how do you communicate a change to a volt-watt curve or a power factor, or, there's something like 15 smart functions that are part of IEEE 1547, and all of them have to be communicated to the smart inverter, which is either sitting on the charging station or in the vehicle itself. OCPP does not currently support those, it doesn't have functions to support sending that information. Now, they're hard at work on implementing those, and we'll see how long that takes and how good a job they do. They're basically copying the IEEE 2030.5, function sets. But we'll see how they do with that. The 15118 does not support it either. They have some rudimentary stuff for what they call V2G, but it is not nearly adequate for what we need. Now, they're also in the process, they have a working group, finally, that's just started to see if they can come up with a solution that will satisfy the US marketplace, because they recognize they're going to lose out if they don't do so. So I've got some notes here about, what they're doing and when they'll do it. So again, now, the other note here that's of significance is the NEVI stuff, which is the National Electric Vehicle Infrastructure. It's the requirements for the charging stations that are funded by the IRA. We got, what is it, $6 billion or something going into that, $7.5 billion. They do not really address V2G. Okay, so all the requirements, they do have a notion of a -20 15118, which doesn't really address what's needed, and an OCPP, but not the version that's going to address the grid codes. So we don't currently have that being addressed in the national standardization of the charging infrastructure. I'm not going to spend time on this. We need to figure out if the standards can coexist. I mean, there's nothing wrong. You use 15118 for managing charging and IEEE 2030.5 or SunSpec or something for managing the V2G. Can we do that? We need to actually find out. And it's already been demonstrated by Stellantis and some partners. But, we need to see if that can scale. Now, I don't know if people, for those who've been following it, Tesla has been watching long enough, and Tesla has by far the best and most reliable charging infrastructure in the world. And that's undisputed. But it's been a closed system, right? And it's been very interoperable. I assume we got a bunch of Tesla owners here. If you've got a Tesla, you can go up to a supercharger, plug it in and get a charge, no problem. What they said is, hey guys, why don't we open up that system to all our competitors and to sort of, shortcut the whole issue of having interoperability problems. And I haven't talked about that, but there's a huge interoperability problem on the current infrastructure. You've got a 20 to 30% chance of not getting a charge if you, go up to a public charging station anywhere in this country and plug in your electric vehicle. And that's not acceptable. And so, Tesla, and I don't expect Tesla to do anything which is really for the public interest. It's doing it for its own interest, but its own interest is to see the rapid adoption of EVs. And that's going to be helped by a charging infrastructure, which is reliable, okay? And customers who are more comfortable that they can get a charge whenever. So they're opening up their network now. The details of that are still being discussed, but the first part of that was to offer their plug, which they claim is a better plug than the current one. And so that's being standardized now. And so now you can picture, all vehicles having a NACS adapter. The NACS is North American Charging Standard, which the SAE is in the process of standardizing on a fast track. But they're not really addressing yet V2G. at least publicly. And so even with this, we know we're going to have the interoperability problems. And we're also going to have a whole bunch of confusion because a bunch of the automakers who are working with Tesla also announced they're going to do their own charging infrastructure to compete with that. So anyway, so it's sort of a wild, wild west and a real mess. So I just want to put in a plug. Jamie mentioned the V2G forum. The next one is coming up in Detroit, October 18, 19. Unfortunately, it conflicts with Grid Forward, which I would love to go to. But this one, I'm chair of the program committee, so I probably have to go to this one. We're going to do a half-day workshop the day before the conference to help people who just want to get basics and understand what V2G is. And then I've done 2 or 3 of these, and it's been really useful for me to do them. And people have told me they've been valuable to them. So, and then there's we'll have the learning day, which is going to be panels and breakout sessions and so on. And then we're going to have a working day, or at least an afternoon, where Southern California Edison has something called a technical advisory board for V2G. And they've got some work groups, and they're going to get together, and then we're trying to get a working group together on the policy and business side of V2G. So I think with that, I would like to just leave in summary for this group that V2G is such a compelling opportunity. I think that GWAC should at least try to answer the question, is there something GWAC can do to help in this area? And that it's coming. I mean, the other thing is I'm just blown away by the amount of interest in V2G. We've got a lot of, we put out a call for papers for this second conference, and we had 30 responses to it. Jamie's going to actually head up the session on the standards and harmonization, which I'm grateful to Jamie and PNNL for. And I'd leave it that everyone should understand the whole, from an interoperability standpoint, a business standpoint, and a policy standpoint, this is the Wild Wild West. This is an area with a huge opportunity, and it's a god-awful mess in terms of how it's evolving.
Thank you, James, for the great presentation. For more information about the GridWise Architecture Council and to view more presentations like this, please visit gridwiseac.org or subscribe to our YouTube channel at the link provided below. Thank you.